be explaining my VLSI project. So earlier we had made this adder. So to this we'll be adding a few more IPs. So with that we'll be starting with my project. So basically what my project is like, with the help of ML model, we'll detect the handwritten digits which is kept on a paper. When you click on the push button 0 on the pink board, it will detect the first number. It will run the handwritten digit through the ML model. It will recognize what digit it is. Then we'll have to press the button 1, push button 1 on the pink board. Then it will scan the image again, the handwritten digit again, and then it will run this handwritten digit through the ML model. It will detect what is that number, and then what it will do is it will take these two numbers and send it to the PL part, where both of them will be added, and you will get an output back in the Jupyter notebook. So here what all we are integrating is, we are integrating IP. Basically we are sending these packets through my phone. So we are doing a basic streaming, video streaming through my phone. We are hosting it locally on a server through Wi-Fi. So what we'll do is, not a server, through Wi-Fi. So what we'll do is we'll send these packets to the pink board. The pink board will process, and then we'll get the outputs. So initially this is the block diagram which we made for the adder. So here we'll have to do an additional few things so that we can get the buttons. So first thing what you'll have to do is you'll have to right click here, add IP, and then GPIO, AXI GPIO. So you'll get this. Now we'll have to adjust the width of this GPIO. So you'll have to double click on that and then click IP configuration, then make this into 4. And then once you have done that, you can click on OK. So now you'll have to do the run connection automation, which will connect all the other stuff to this. So you'll have to click on all automation and then OK. So now we have gotten this. Now what we'll have to do is we'll have to connect it to the physical buttons which is there on the pink board. For that, currently we are in the sources tab. Now we'll have to go to the boards tab. So in the boards tab, you can see all the switches and everything that is available in the pink board. So what we need are these 4 buttons. So you can click on this, the 4 buttons which is here. Now you can right click on this and you can connect board component. So once you click on this, you get a pop-up will come. You can click on OK here. So once you click, it has already done the connection. As you can see, you'll get an external output. So now we'll have to save this, and then we'll have to validate the model. So now the validation is successful. Now we'll have to generate a bit stream. So you'll have to click on generate bit stream and then save. Yes. Okay. So basically I've already created a bit stream for this. So what you can do is you can go to the place where I've saved this. So that will be File Explorer, D drive. There'll be something called as add_final, and then you can search for 3 files. One is .tcl, that is this. Then what you'll need is a .hwh, that is this, and then you will need a .bit, so that is this. So these 3 files you'll have to take. So I've copied them here. So these 3 files, and then you'll have to put it in the pink network directory. So that is, I'll explain to you. So you'll have to copy this, and then you'll have to go to networks. In networks, you'll have to, for opening the Xilinx directory, you'll have to do //ping. Then you'll get the Xilinx directory. Then you'll have to search for overlays. So once you click on overlays, you'll get something like this. So I've created this folder called gesture. In this gesture, you can just drop these 3 files, .bit, .hwh, and .tcl. So once you're done with that, now we can open Jupyter Notebook. So for that, what you'll have to do is you'll have to open Chrome. In Chrome, you can, by opening Jupyter Notebook is very easy. You'll have to do PYNQ-Z2 When you click on enter, you'll get something like this. So I have actually saved this file in a certain folder. I will show it to you. So you'll have to go to get started, and then go to Abraham_data, and then this is the name of the file which I've created. When you click on that Jupyter Notebook will open. Yes, so now Jupyter Notebook was open. So this is basically the overlay file where the wrapper is present, or the bit file is present. Now this is initial tries which I tried with KNN and all that stuff, but then unfortunately we didn't get the desired output. So what I did was I used the SVM. So using SVM model, we did this. So basically what we did was we trained on this data set. So this is called the MDIS data set. So this has all the handwritten drawings of every digit. This is number 0, number 1, number 2, number 3, number 4, 5, 6 7 8 9. So basically all the digits. So it is first it will train on this data set, and then it will detect the digit. So then now what I did was, initially I tried with a video camera. So unfortunately that was a it was a good quality camera, so the PYNQ board couldn't handle the camera. We had to install a few drivers which was very hard to install on the PYNQ camera, so we had to create a IP stream from a camera which is in the phone. So this is the stream URL. So what you can do is, you can download this app called IP web stream on Play Store, and then you can share your web stream. So when you do that over your local Wi-Fi, there will be a stream created. So this is the IP for that. You can click on this, and then you can put it in this code, whatever is your code, and then write packets from the camera to the PYNQ board. So this is the URL, and then what you can go down, and then you can see. So here we'll be first writing the first number to the PL part, then we'll again write the second number to the PL part, and then the addition happens in the PL part, and the result will be read from the PL part. So basically what happens is, when we run the code, what happens first is, we will download the dataset. It will train the SVM model based on the dataset which was shown before, and then what happens is, it will ask us to click the button 0 on the PYNQ board. So when we click the first button on the PYNQ board, it will take a camera, basically a frame from the camera of the first camera of our phone, and then what you can see is, you can see closely, it detected number 2 handwritten, and then it was sent to the ML model. It processed, and then we got the first output, captured output as input as the number 2. Then it asks us to press the button number 1. So when you press the button number 1, again the camera is on, a frame is sent, and then the number which is handwritten number is 5. So this is sent again to the ML model, where it is processed, and then what happens is, you'll get the captured output as captured input as number 5. So then what will have to these two numbers will be sent to the PL part, where it will be added. So 2 plus 5 is equal to 7, and then this is sent back to the Jupyter notebook, where we can see the final output. So this is my project. Thank you. Yes sir, instead of image compression, what I was working on this, so I thought I'll do this. So these are handwritten numbers, sir. So like the model will first detect the handwritten number, then it will open the we have already trained this based on this data set. It's called MNIST. So MNIST data set, it has all these handwritten numbers, so like all these data set. So 0 1 2 3 4 5 6 7 8 9. So we are using SVM to train this. So SVM, so support vector machine, so we are using that to train this. So initially what will happen is, like the camera will detect the numbers. Like I have handwritten few numbers under this, so it will detect the numbers, and then these numbers first when we press the button on the PYNQ board, so these are the two buttons. So when we press the first button, it will activate the camera, and then it will take one frame. So it will detect this handwritten drawing, and then it will compare it with the data set, and then it will say which number it is. So we'll get the 2 first, then we'll have to press the second button. So second button, when we press, again the same thing will happen. It will take the number 5, and then it will do the data set, it will compare it with the model, and then we'll get the output. And then this is done in the PS part. So, and then this is sent to the PL part, where the addition is taking place. So initially we tried with the video cam, but the problem is, like video cam required few libraries, but then that was not supported by the PYNQ board. So we had to switch to mobile. So in mobile, what we are doing is, there's this app called IP webcam. So here we can like share the IP, like we can stream this over the Wi-Fi. So this is the IP for this, and then like in this code, as you can see, like here sir, like this is the IP. So from the phone, this video is being streamed to the PYNQ board. So and then over here, like this URL, so this is the model which I was explaining earlier, MNIST model. It will train based on these handwritten, and then it will predict the output. So yeah, this is how it is happening. So now like we'll run this. As you can see, it is downloading the dataset and training the SVM model on the PS part. Now training has been done, and now it is asking for button 0 to get the first input. So this is the button 0, push button 0. So when we press the, now like I'll take the camera. So when we press the push button 0, yes, as you can see, it has detected the first number 2, and now it is asking us to push the push button 1. So this is the push button 1. now I'll just move it to a different number like 5 here. So now I'll press push button 1. Yes sir, so the captured logic is 5. So the second number also we have detected it as 5. Now this two numbers will be sent to the PL region. So in the PL region it will add. So 2 plus 5 and we'll get 7. So here what we have done is we have integrated a IP webcam. We'll be sharing the package through the local Wi-Fi. So IP streaming. So first then the package will be sent to PYNQ board, and then we are using the push buttons to get the inputs, and from this we will be taking the handwritten digits, and then with the help of ML model we'll be comparing it with the already predefined data set. This is all the hand drawings, and then we'll come to an output. We'll get the first number, then we'll again push the next button which will ask for the second input. So second input will be taken based on this drawings which we have made, and then it will be again put in the ML model. We'll understand which number it is, and then we'll send these two numbers to the PS part, and then once we do that, then we'll to the PL part. Once we do that, the PL part addition happens, and then we'll get the output results. So for this this PSPL integration, what I initially did was through Vivado I generated one package. So and then I generated a bitstream. So bitstream will have 3 files. I'll show you the files. Yes sir. So this is the design one wrapper, design one HWH, and then design one TCL. So these 3 we'll have to put it in the PYNQ overlay directory, and then once we do that, like I can show you the directory. This sightings directory, and then we can search for overlay. This overlay directory, this gesture I have put it here. So once we put it here, it will come to the PYNQ Jupyter notebook. It will be uploaded here. Then from this we can import this overlay. This is the the path for that, where I have shared everything. So in that path we need to have 3 main files. One is .hwh, .bit, and .tcl. So this can be taken from the place where we have put the bitstream from the Vivado, and these 3 will have to put it in this, and then we'll have to get the path. And these are the addresses for the input output, like the buttons, pins, from which we have to take the input. So from this, these are initial tries which I did with different other models like KNN and other models. Linear regression also I tried, but it was not working. So we are getting some waste outputs which we couldn't run it anywhere. So then we used SVM. So in SVM we got desired output. This is the methodology. Yes sir, thank you sir.